Good morning, students. Today we are going to discuss the numericals on Kirchhoff's rules. Right? So Kirchhoff rules are applied in the circuit which is complicated, where we cannot apply the Ohm's law. Right? So there are two rules. One is junction rule. The algebraic sum of all currents meeting at the junction is equal to 0. And second one is the loop rule. Loop rule states that the algebraic sum of product of current and resistance and the EMF in that particular closed loop is equal to 0. So there are few questions. This is the question based on Kirchhoff's rule. Now see this network. We have three batteries E1, E2 and E3, right? And the direction of currents are given. I1 is going in this direction, I2 also in this direction, and I3 is going in this direction. So we have to find I1, I2 and I3. Now you can see here three resistors 4 ohm, 4 ohm, 4 ohm are connected towards the negative terminal of the battery. Now students, we have the loop rule summation of IR plus summation of E means EMF, that is equal to 0. This is the loop rule, right? Now what we have to do, first one, we have to apply the junction rule. So there are two junctions. These are the two junctions. At this junction, I3 is incoming current and I1 and I2 are outgoing current. So we can write I3 is equal to I1 plus I2. ठीक है ना? ये हमारी पहली इक्वेशन बन जाती है by the junction rule. Now we have to frame the equations from the loop rule. First of all, we have to draw the arrow in anti-clockwise direction, right? So this is the arrow in anti-clockwise direction. This is for the second loop. Now if the current is in the same direction as arrow, means if current is anti-clockwise direction, so we have to take it as negative, and if the current is clockwise, so we have to take I positive as per the sign convention. In case of EMF, if EMF is in anti-clockwise direction, so it should be taken as positive, and if EMF is clockwise, then it should be taken as negative, right? So first, for the first loop, we have to frame the equation. So what will be the equation? Current into resistance. So what is the current in this 4 ohm resistance? I1, and this current is clockwise. It means it should be taken as positive. So 4 into I1, current into resistance. So resistance is 4, current is I1, right? For this one. Now second resistance, you can see that I2 is going in anti-clockwise direction, in the direction of arrow drawn by you, right? So this is anti-clockwise current. So it should be taken as negative minus 4I2 plus. Now there are two EMFs, E1 and E2. E1 is anti-clockwise, so it should be taken as positive. So this is plus 2. And this battery EMF E2 is in clockwise direction. This is in clockwise direction, so it should be taken as negative, is equal to 0. So this is the first equation. Similarly, for the other loops, we can calculate the values, and after solving these equations, now there will be 4 equations. Number 1 for junction rule, number 2 for first loop, right, this one. Third equation will be for this loop, and the fourth one will for the entire loop, outer loop. Then we have to calculate all the values I1, I2 and I3. So this is the answer of this question, right? Now question number 2. In the given circuit, assuming that A is at zero potential, this point at zero potential, use Kirchhoff's rules to determine the potential at point B. Now we have to calculate the potential at B, right? Now see, this is the 3 ampere current, this is 1 ampere current. So what will be the current in this branch DC? That will be 2 ampere. If this battery is giving 3 ampere current, 1 ampere current is going in this direction, so remaining current will flow from this one. So what will be the potential difference across this portion? It will be current into resistance, means 4 volt, right? So the potential difference between D and C is 4 volt. This is 4 volt, right? Now A is at 0 volt. A is at 0 volt. So what will be the voltage at point C? That will be 2 volt. Why? Since there is a battery, and if it is A point is at 0 volt, it means C will be at 2 volt. If it is 2 volt and the potential difference across this portion is 4 volt, it means the potential at D should be at 6 volt. It should be at 6 volt. Now this is the battery of 4 volt. If it is 6 volt, so what should be the potential at point B? That should be at 2 volt, right? So this is the potential difference. So we can see that the current in DC is 2 ampere. Voltage at C is 2 volt. ये C पे 2 volt है. क्यों भाई? क्योंकि यहाँ 0 है तो यहाँ 2 volt होगा. Now VD minus VC should be equal to 4 volt. क्यों भाई? क्योंकि 2 एम्पियर के करंट है, 2 ओम का रेजिस्टेंस, तो 4 वोल्ट हो गया. इसका मतलब VD 6 वोल्ट पे होगा. If VD is at 6 volt, it means VB should be at 2 volt. है ना? इस तरीके से इसे सॉल्व कर सकते. Now next question, in the circuit diagram find the potential difference across the plate of capacitor. Now this is the capacitor. Student, you know that capacitor always blocks the DC. ये ब्लॉक कर देता है DC को, तो there will be no current. तो करंट किधर से जा रही है? इधर से, I. There will be no current in the middle branch. ठीक है? तो आप इसको सॉल्व कैसे करेंगे? सबसे पहले हम क्या करेंगे, इस पे किरचॉफ्स लॉ अप्लाई करते हैं फॉर द आउटर लूप. किरचॉफ लॉ जब आप अप्लाई कर देते हैं तो यहाँ पे I की हमारे पास वैल्यू आ जाती है 1/20. ठीक, अब 1/20 आपके पास वैल्यू आ गई है. यहाँ कोई करंट नहीं है. इसका मतलब A पॉइंट और D पॉइंट के बीच का वोल्टेज कितना है? 1.5 वोल्ट. हो गई हो तो, है ना? इसका मतलब क्या हुआ कि अगर ये 1.5 वोल्ट है और A और B के बीच का पोटेंशियल डिफरेंस भी 1.5 वोल्ट है, इसका मतलब देयर इज नो पोटेंशियल डिफरेंस अक्रॉस कैपेसिटर. तो द पोटेंशियल डिफरेंस अक्रॉस द कैपेसिटर विल बी 0, राइट? नेक्स्ट क्वेश्चन, स्टेट Kirchhoff's rules. Now this is the theoretical question, no need to solve it, but the use of Kirchhoff's law to show that there is no current in the circuit. आपको ये प्रूव करना है कि इसमें कोई करंट फ्लो नहीं हो रही. तो इसका मतलब ये जो I है इसको हमें 0 कर देना. Now see, first of all we have to draw the anti-clockwise arrow. Now current into resistance. कौन सी करंट जा रही है इसमें? I की डायरेक्शन क्या है? एंटी क्लॉकवाइज. यहाँ पे भी डायरेक्शन ऑफ करंट क्या है? एंटी क्लॉकवाइज. तो बोथ करंट्स आर एंटी क्लॉकवाइज. इट मीन्स इट शुड बी टेकन एज नेगेटिव। ये आ जाएगा I इंटू R1 और यहाँ भी क्या होगा माइनस I इंटू R2, ठीक है, क्योंकि एंटी क्लॉकवाइज है इसलिए नेगेटिव लिया। अब इसकी वोल्टेजेस देखो बेटा, ये वाला तो एंटी क्लॉकवाइज EMF, तो इसे हमें पॉजिटिव लेना पड़ेगा। ये वाला है क्लॉकवाइज, है ना, तो इसका मतलब इसको हमें नेगेटिव लेना है, तो इट इज इक्वल टू 0, ठीक। अब 2 minus 2 is 0, we can take I R1 plus R2 is equal to 0, किया जा सकता है, तो it is equal to 0. Now R1 and R1 plus R2 cannot be 0, it means I is equal to 0, so there is no current in the circuit. वैसे भी आप जानते हैं जब दो बैटरी अपोजिट डायरेक्शन में लगी हो और उनकी वोल्टेजेस सेम हो तो वहां पे कोई करंट फ्लो नहीं हो, ठीक है। तो दिस इज ऑल अबाउट द न्यूमेरिकल्स बेस्ड ऑन किरचॉफ्स लॉ। थैंक यू वेरी मच।